Well, good afternoon. It is day 6 of our Chemistry B, Unit 6, States of Matter and Gas Laws. This is part 2 of day 6. We have talked about we've talked about Boyle's and Charles' gas laws, and now we're going to talk today about Gay-Lussac's gas law as well as the combined gas law. So, let's get it started. All right. Boyle's and Charles's gas law dealt with their pressure and volume and temperature and volume. And today we're going to talk about Gay-Lussac's law, which deals with pressure and temperature. And since you don't see volume listed, then volume is the factor that is constant. Okay? So Gay-Lussac's law by definition states that as the temperature of an enclosed gas increases, the pressure increases if the volume is constant. So, therefore, if one goes up, so does the other. If one goes down, so does the other. This is a direct proportion to the Kelvin's temp. Okay, so in this one also we have to add Kelvin to it. And the pressure of a gas is directly proportional to the Kelvin temp if the volume remains constant. So the line would be straight or it would be curved. Which one? Directly proportional. Is the curve straight or is it curved? It's directly proportional, so it's a curve. It's a straight line. It's a straight line. All right. So here is our mathematical expression. P1 over T1 is equal to P2 times T2. All right. And at this point, let's take a look at page 423, sample problem 14.3. Okay. Aerosol cans carry warnings on their labels that say do not incinerate or store the cans above a certain temperature. This problem will show why it is dangerous to dispose of aerosol cans in a fire. The gas in a used aerosol can is at a pressure of 103 kPa at 25 degrees Celsius. If the can is thrown into the fire, what will the pressure be when the temperature reaches 928 degrees Celsius? So, the first thing we have to keep in mind is Kelvin. Just like Charles's law, Gay-Lussac's law requires Kelvin. So you have to add 273. All right? So let's take a look at this, and let's look at what we know and what we don't know. All right? Our knowns. We know that from our reading that pressure number 1, the starting pressure, was 103 kPa. We know that our starting temperature was 25 degrees Celsius. We know we have to make that into Kelvin, so that makes that 298. And we know that our final temperature, or our T2, was 928 degrees Celsius. We have to add 273. And when we add 273, we get 1,201 degrees Kelvin. All right? And what is our unknown? What would be our pressure? Now, our formula is P1 over T1 is equal to P2 times T2. Okay? Now, plug and chug. Well, we have to solve for the unknown. The unknown was right here. So we know that it's going to be this multiplied by this divided by that. So let's plug our numbers in, and we're going to get P2 is equal to P1, which is 103, multiplied by, so here's our cross reference, our cross right here, P1 times T2, right here. T2 would be 1,201 Kelvin, and divided by T1. T1 is 298 Kelvin. And when you multiply 103 times 1201 divided by 298, then you are going to get 415 kPa. And that's how we do that. All right, next is the combined gas law. The combined gas law is a combination of all three gas laws, so Charles, Boyle's, and Gay-Lussac, which describes the relationship among the temperature, the pressure, and the volume of an enclosed gas. Okay? This will allow you to do calculations for situations in which only the amount of gas is constant. Our mathematical expression, or our formula, is P1 times V1 over T1 is equal to P2 times T2, P2 times V2 over T2. All right? Now, to solve for this, before we get to our sample problem, I'm going to show you how to solve for the for an unknown here in just a second. Okay, so here is our combined gas law formula. How are we going to solve for this? Well, we're going to use the same idea of cross multiplying as we did in the other gas laws, but we have to remember that things follow with this, and we have to get this onto its own. So here's what happens. All right, this is going to multiply this right here. It's going to be multiplied into that. All right, and this will also multiply to this. Okay. Okay. So now we have to rewrite this. So this P1 right here, that I just marked with the little dot, is going to multiply by T2, but it also has to bring V1 along. So here's what ends up happening here. It ends up looking like this. T2 multiplied by P1 times V1, okay, is equal to, and then the same thing goes across over here. T1 right there, multiplied by V, or P2 times V2. All right? And that is now where we're at. So that is how we get our equation so that it's easy to solve for the unknowns. Okay? So remember that when we get going through here, because we're going to continue now with the sample problem. Okay? So if you're on page 424, it says the volume of a gas-filled balloon is 30 liters at 313 Kelvin and 153 kPa. What would the volume be at standard temperature and pressure? Now remember, standard temperature and pressure is 101.3 kPa. So that does give you enough information. So let's take a look at the knowns. The knowns. Our first volume, V1, is equal to 30.0 liters. Our T1 is at 313 Kelvin. Now remember, Kelvin is already listed, so we don't have to add 273. It's already listed in Kelvin. If it was in Celsius, we would have to do so. All right? P1 is equal to 153 kPa. T2 is 273 Kelvin, because that's standard temperature, and standard pressure, which is P2 is equal to 101.3 kPa. Now, here's the deal. I will not give you will not have to memorize T2 and P2, in other words, 273 and 101.3, but I'll make sure that the problems already have that listed. So, what is our unknown? Our unknown is V2. Unknown is V2. So now we have to solve for the unknowns. So as we solve for the unknown, we have got to get rid of T1 times P2. Now let's remember our order of operations. This really turns into, with these parentheses, is still multiplication. So this number is multiplied by what's inside. So what ends up happening here is we have to get our unknown V2 by itself. How are we going to do that? Well, we're going to divide each side by T1 times P2. So T1 and P2, remember there's a multiplication sign there. So it's T1 times P2. All right, what ends up happening next? Of course, we know that this cancels each other out. And that leaves us with V2. Okay, so now plug and chug the numbers. T2 is 273 times P1 is 153 times V1, which is 30 liters, over T1, which is 313, times P, this would be P, that would be P2, sorry, somehow I didn't carry that over, P2, which is 101.3, all right, and when you do that, you get 39.5 liters. So V2 is equal to 39.5 liters. Okay? So, quickly, here's our starting formula. We're going to take this and multiply it by this, and we're going to take this and multiply it by that. And that is going to get us to T1 times P2. Okay? And then to divide it, we get to that point here. All right? We'll talk more about this tomorrow. And this is the combined gas law.